Okay, so now we're going to look at this function and identify three characteristics. The first thing we're going to do is find the zeros, then we're going to add up the degree, and lastly we're going to write the end behavior. So for the first one, both of these are in factor form. So all we need to do is set the factors equal to 0. When it's in factor form, it's really simple to find your zeros. So we have three factors, but that -3, because it doesn't have an x, it does not have an x-intercept. The only thing that -3 is going to do is change the end behavior, which we'll talk about in a little bit. So the first thing we're going to do is set the first factor equal to 0, which is x plus 2. And when we solve that, we get a 0 at -2, 0. So we have an x-intercept at -2, 0. The second one, x minus 4. So we also have an x-intercept, or 0 at 4. The degree. When I add up my exponents, I have 2 plus 1, so that means it is a third degree. The leading coefficient, I'm going to go ahead and write that in because that is important for our end behavior. The leading coefficient is actually -3. So now, when you're trying to determine what is this graph going to do at the end, well, again, because this has a -3, -3 tells me that it is going to decrease. So on the right, it is going to fall. Because my degree is odd, it's going to do the opposite on the left. So when I write my end behavior on the left, when x is getting smaller, f of x is getting bigger. Or as x approaches -infinity, y is approaching +infinity. On the right, as x gets larger, f of x is getting smaller. And that is my end behavior. Let's do the same thing with the second function. So this second function, if I count up my exponent, the exponent on these factors are 1. Because you don't see a number, that tells me that the exponent is a 1. So we have a 1 plus a 1 plus 2. 1 plus 1 plus 2 gives me a degree of 4. The leading coefficient is 2. So I'm going to abbreviate that LC, and that is 2. Okay, so to find my zeros, I have x plus 1 equals 0. And then I have x minus 3 equals 0. And then I have x plus 5 equals 0. So my end behavior, because my leading coefficient is positive, that means it's going to increase on the left. And because it's an even degree, it's going to do the same thing. Because my leading coefficient is positive, that means it's going to increase on the right. And because it's even, it's going to do the same thing on the left. So on both sides, it is going to rise. So I'm going to just write this as one behavior because it is the same. So as x approaches positive and negative infinity, f of x is going to increase and approach positive infinity. So now we're going to talk about, well, what does this mean? These exponents, okay, because these exponents on the factors, they're really important because it tells us what the graph is going to do at that 0. So there's only two things you need to keep in mind when we're talking about behavior. There's two different behaviors. Either A is going to cross the x-axis, or it's going to touch or bounce. Okay, so let's look at this example here. We have two different factors. Okay, so this function has a 0 at x equals 1. But the exponent is also 1. So because this was an odd number, because it's odd, it is going to cross through the x-axis. It's going to go through at that point. The second 0 is at x equals positive 4. But this is squared. So it's going to have a different behavior at these two zeros. This factor has a degree of 1, so it crosses through. The graph goes through that point. This factor has a degree of 2. So the graph comes down, touches it, but then bounces back up. And that's really important as we graph. So let's go ahead and take a look at 2 more functions. And let's go ahead and graph it. Feel free again to pause the video at any time. All right, so we have 3 factors. We actually have x 3 different times. All right, so I'm going to go ahead and fill in my degrees. This has a degree of 1, this has a degree of 1, and the last one has a degree of 2. So that means that I have an x-intercept at x equals 0. I have another one at x equals negative 4. And my third one is at x equals positive 1. Because both of these factors have an odd degree, it is going to cross through the graph. It's going to go through at both of these points. But at x equals positive 1, because it is squared, it is not going to go through it. It's going to touch, but I also like to say it's going to bounce. If you think of the x-axis as a floor and the graph as a ball. Okay, the last thing we need to talk about is, because we're going to pull all of these key things together. So we know all together this is a 4th degree. So it's even, which means the behaviors will be the same. And because it's positive, we're looking for a graph that's going to go up on both sides. So both sides is going to go up. So let's keep all that in mind as we do a sketch. Now, when we sketch it, I am going to put my first point at, is going to go at x equals 0. So I'm going to put my point here. And then I'm also going to put a point on x equals negative 4. And then the last one at x equals negative 1. So I know that because this is an even degree, that on the ends, they're both going to go up. So I'm going to go ahead and put that on my graph. And now I'm ready to fill in the middle. Okay, so I know that at x equals negative 4, the graph is going to go through. So it's going to come through. So it's not going to bounce here. It's going to move through. So because it moves through at negative 4, and it also goes through at 0, then that means it's going to have to just it's going to bounce off the 1. So when I am drawing my graph, and again, we don't know unless we actually plot points. It's hard to know exactly how low it would go, but we know that it is going to go through, it is going to come back up, and then when it hits this point, it is going to bounce. Okay, let's do one more. All right, so this one is not in standard form, so the first thing we need to do is factor it. So we're going to take out our GCF. And then we're going to factor that down. We need 2 numbers that multiply to be negative 12, but add to positive 1. So when I set these factors equal to 0, now I can get my 3 x-intercepts. Now notice that for this function, they are all odd. When you don't see a factor, that means it is 1. So I have a 0 at the origin, and because the degree is 3 and that's odd, it is going to go through. I also have one at -4, 0, which is also going to go through. And I also have my last one at +3, 0, and that is also going to go through. So we don't have any bounces in this function. I'm going to plot my 3 zeros. Okay, so I have one at -4, and then I also have one at 0, and then I have one at a +3. Now this is a positive leading coefficient, which tells me that the end degrees or the end behavior is opposite. Because it's positive, it is going to increase on the right. It's going to do the opposite on the left. So because they're all even, because they are all odd and it goes through, I'm just going to go through, come up, make a U-turn, come back through, come up, make another U-turn, and that is my graph. That is a 5th degree function.